Yeah, so this being our day 11, we are going to cover smart contract web frontend. And like I said, we'll be covering two ways that you can write a web frontend to your smart contract. So the very first one is going to be a very simple, we're going to work with a very simple web project. Then the second one will be doing a React project. So we'll also see how to implement this in our Rust projects. Then if you don't have an idea, if you're still ideating on your demo project, please finalize, then start working on them as soon as possible. I actually expect you guys at this point to be able to do your demo project because we've covered the main concepts that you need in writing your demo project. So please go ahead, start them off, and looking forward to see having you certified. That is. Now, in my list today, you realize I have in my list of what we need, I have two other points or items added. That is the near API JS. That is basically what you're going to work with in this session and our session tomorrow. Then you need some JavaScript skills as well. So if you have some JavaScript skills and you have this package in place, then you're good to go. So we're basically going to walk through a simple web frontend of Wishlist smart contract. I already did this, guys. If I decided to do this during the session, then you'd spend a lot of time working this out. So I decided to do this before the session. So we're just going to walk through what I already did. So if you have any question, please feel free to bring them forward and we'll respond. Awesome, great. So let's see what we're going to do. I really hope you can see my VS Code screen. Can someone confirm, please? Can someone please confirm if you can see my project, the VS Code I just opened? Okay. Well, Destiny, you never missed anything. Welcome. Okay, thank you. Great. So you realize I just opened the sidebar of the VS Code app. And as you can see, is a very simple web frontend. Okay. So if you're just coming from a boot camp where you're taught to do some very, these working with the simple HTML, you should be good to go because this one is a very simple one. So we have our CSS, JS, and fonts folder in place where the CSS folder is going to carry all our style sheets. So in this case, I'm actually using Bootstrap. It's a Bootstrap application. Then right here, we have font awesome fonts and our JS inside here. So we're going to walk through all the files, don't worry. Now, our entry file is index.html file, and this is going to serve as our dashboard, okay? So if any of the user that is going to use our application is not going to be authenticated, then they'll first be redirected, to the auth.html file. Then in case they want to add a record, so in this case, a car record to their wish list, then they'll be directed to the new.html file. And maybe we can walk through, I want us to walk through the app first before we even go through the code. So we're just going to walk through, let me open this. So I'm going to run it locally. Yeah, so this one is running locally within my machine. So it's not yet online, it's not hosted yet. Okay, so this is the interface. So this is the auth.html. Apparently we are not authenticated. Okay, now I'm going to, so right here we are told that authentication is required. So I'll just click on the login button. And then clicking on that, I'll be redirected to my near wallet interface. And I'll be prompted to select the wallet address that I want to proceed with to log into this particular application. So right here, I have our yto.testnet. So we've been using, actually, this is the wallet address we've been using almost throughout the course. So I'll just hit on next. So this is going to display some permission information over here, connecting with yto.testnet. Only connect to sites that you trust. Once connected, localhost will have limited permissions. So that is just some warning. So our smart contract or this application will be able to view the address of your permitted account, view the balance of your permitted account, call the methods on the smart contract on behalf of your permitted account. This does not allow the app to transfer tokens though, okay? So we're going to, the smart contract behind our application is under this address. And if you can remember in our previous sessions, this is where we deployed it, okay? So really take keynote on this. I'm going to show you how we put that there. Then here, the network fee allowance is 0.25 NIA. So the application will be given permission to spend up to 0.25 NIA towards network fee incurred during the use. So basically, what you're going to use for our gas fee, okay? So I'll just hit on connect. And that should connect to our app and redirect us back. Awesome. So you realize I'm apparently in our application, so the dashboard of our application. And right here, I have the wallet address apparently connected. So you can either add new car or log out. Those are the options we have right there. And apparently I have a car record, one car record, the one we've actually been using. So I'll just hit on new. Then I'll just provide the same image. Let me see if we can find another image online. Guys, what's your favorite car? Tesla. Okay, so Tesla image. Tesla car image. So we can go with this. Looks good. So I'll just grab the link to this particular image. I really hope you're going to get it. Let's see. Great. So I've just grabbed the, if I can get back here. Oh, no. Awesome. So I just grabbed that. So I'll just paste it right there. You can give it Tesla. What is the model? Give it anything for now. The mileage, 0 mileage. Then the price is, can give it 1 million, 2024 model. So I'll just hit on add. And you realize, guys, when I hit on add, I'm again redirected to my wallet address. And again, you're going to see why this is happening. So at this point, I'm redirected again to my wallet address with this information that I'm going to use 1 NIA, or my application, the application I'm using is requesting 1 NIA. This is equivalent to $3.35. So these will basically be deducted from this wallet address, the estimated fees right there. And you can as well get more information right here. So this contract, it is going to be used on this contract. And this amount of token is going to be used to invoke this add car function on this particular smart contract, okay? So that is it. So I'll just go ahead and approve. After approving it, it will send the 1 NIA to our smart contract or to our application for us to use it within our smart contract. Now, that was just successful. And if we check our console, that is our browser console, you realize there's no error. So we can just click on back, and it's going to take some time. If you are JavaScript, if you're good with JavaScript, you can put this progress functionality. But for now, I'm having a synchronous function within my app, so that's why you see some delays happening here and there. But in my list, we have the 2 records now. So I have Tesla and I have the Toyota record. So these are the records I have within my wish list. So I can just go ahead and remove as well if I want. So if I click on that delete icon, it will also take some time to do the promise. Then it will reload for me to see a fresh record. So in this case, you expect just one record. So yeah, as you can see right there. So, oh, so we have model I3. We're going to use this, Alan. Cosmos 1 year was $5 last week. Yeah, I think it just dropped again to $3 if I'm not wrong. So now let's move now back to our code, and let's have a look at what's really going on in our application. Okay, so I'll really not walk us through what we have, the HTML. I really hope you're familiar with the HTMLs. Okay, so I'll not be talking about what you have as a HTML and all that. I really hope you've seen the interface and you can be able to figure out how the HTML is likely to look like. I'll not again talk about CSS and the fonts. I'll just head on to JavaScript. Now I'm using Bootstrap, and the three main files I'm going to talk about are the config.js, the index.js, and the utils.js. So we're going to start with the config. So in our config.js file, we're basically doing the configuration. So basically connecting the information you need to connect to our smart contract on the NEAR protocol blockchain. Now you realize that the very first thing I'm doing right here is providing that is line 1, the contract name or the wallet address where we actually deployed our smart contract. Okay, that is what is happening in line 1. Then line 2, I'm just giving the app name. So I just called it car wish list. Then I have one function within this file. If I can just minimize that, you realize I just have this one function within this file, and it has a switch statement. So given the parameter or the argument that will be passed into this function, we'll check if it is production or mainnet. Then here is the information we're going to return to connect to a mainnet network of the NEAR protocol blockchain. So you'll be using this if you're going live, sort of. Now, for the purpose of our development, we also have these other case, either development or testnet, and these avails the testnet network details we need to connect to our smart contract that we deployed in the testnet network. Otherwise, we're going to throw an error before we proceed. Now, there's these line 11 and line 21, you realize they are a bit similar. So in this case, there's what we call, when I logged into my wallet address, or when I logged into the app, I was directed to my wallet address. And that redirect basically created what we call an access key, which my app is going to use on behalf of, to do operations related to the wallet account that was attached to it. So in this case, I logged in using my ytr.testnet account. So an access key was generated, which I can now use from my app to interact or to sign transactions within our wishlist smart contract. Now, that access key, based on this configuration, is going to be stored locally on a local storage within our browser. Okay, so it's going to be available within our browser. And maybe if I can show us that, this is our app. So let's have a look at application, local storage right here. You see, so we have these. Here are the keys. I really hope you can see these guys. So here are the keys. So these are the authentication records we need for application. Okay, so that is actually what was stored. It was stored locally within our browser. Great. Let's head back to the VS Code. So that is it about our config.js file. Let's head on to our utils. So this is where I really want to draw your attention to, because we're going to cover a lot right here, and I really don't expect any to miss anything. at this point because this is where the gist is, leave alone the index.js file. That is basically going to help us interact with the front end. But this file is going to help us interact with our smart contract. Now, in line 1 of utils.js file, we're basically bringing in the configuration information in form of a JSON object using the getConfig function we saw in the config.js file. And in this case, we are passing our development. The parameter we are passing is development. So in this case, we're going to use the testnet network. And right here, I have an initialization function. So if you're familiar with JavaScript, this function is going to be declared and invoked immediately, okay? The function will be declared and invoked immediately. And keen enough, it is an asynchronous function, okay? So this asynchronicity is what was making my application seem a bit slow, but the things were running well in the background. Now, I'm passing window as a parameter to this function of mine. And window is basically the global web window, web window object, we know in JavaScript. So in this, I'm trying to assign some global values. That is the NIA, the wallet connection account, and the contract. So I'm trying to assign them as, to add them as global values to my window object. Now, the value I'm going to assign to NIA is going to be, now you realize I'm using these, there's this object I'm using right here. So the question is, where am I getting this object? So again, let's head back to our browser. And we're going to search for, we're going to search for NIA docs, okay? So basically NIA documentation, I'll hit on the first link. This is going to direct us to the NIA documentation. Then hit on develop link, then head on to the front end section, quick reference. Is it here? No. Introduction. Let's see if it's going to be available here. Yeah. Now, so this basically talks about the NIA API.js module we are using in this case. So now that we're basically using a simple web interface and not a module, like it could be the case in Angular, React, and the rest. We're going to pull this library, the NIA API.js library, as a CDN or from a CDN link. Now, there are two ways you can avail this library within your application. So the first one is using this particular CDN to set it up. Okay. So in the project I'm taking us through right now, this is actually what I've used. I'll be showing us where, and then the configuration is all here. So maybe I can drop this in the chat as well, so that we have guys following up. Great. So that is it. Now, like I said, there are two ways to avail this library to your project. If you're just doing a very simple web front end, like our case, you can simply use pull it through this CDN link. But if you're using a module, a node module project, then you can use this npm install NIA API.js, and that will avail the library within your project, and you'll be good to go. Now we'll be using this in our tomorrow session, and we'll see how. So if I just take us to the index.html file right here, you realize before the other JavaScripts we have, I'm pulling it first. I'm pulling it first in our file. So this is actually the arrangement in all the three files. I'll be pushing this into a GitHub repository, so you guys will be able to follow up as well on that. Awesome. So that is where this object is coming from. So I really hope we are at par right there. So this object has a method connect, which is going to accept our configuration data. and it's going to return an object, which in this case we are storing under near variable. Let me just refer to this as variable. Then from the same object, we're going to create a new object instance, in this case using the wallet connection method and passing in the object is stored right here in near. So this will initialize a wallet-based account, okay? So this way we'll be able to work with the near testnet wallet that is hosted at this particular address, right? Then from there, we need to create our account object. So in this case, sort of for us to be able to make all these transactions on the near blockchain and linking them to our wallet address. So in that case, we're going to come up with these, avail this account object. And to do that, we'll basically invoke the account method of the object that will be stored under wallet connection. So this is an asynchronous method. So again, you have to use the await keywords before it for us to get that, that information. Then down in line 14, we are initializing our contract API by the contract name and the configuration information we have. So for us to be able to interact with our smart contract on the testnet network or on the near protocol blockchain, we need this object for us to be able to perform all that operation. And the very first thing we need to do is to initialize, or rather, have the object in place. So we're going to do that by availing the object through running this line of code new near API.contract. So this contract method, we're going to pass in our account object inside here. So this is the account object that is connecting. Then we're going to pass in the contract name. So in this case, like I said, in our config.js file, this is the contract. This is the contract name, basically the wallet address where we deployed our smart contract. So you pass that address over there. Then the very last parameter is a JSON object, which is basically going to take a list of methods. So in this case, view methods. So apparently our contract does not have a view method. It doesn't have one. So that's why the list is empty. But we have change methods. So change method functions or change methods, change method names within our smart contract, the way they appear in our smart contract are all going to be listed here as an array of string. So the very first function we had in our smart contract was add function, sorry, add car, then read wishlist, delete car, and XCC counter. So this was the cross contract call, the cross contract method we had within our our contract. Now, Destiny, sorry for that. Okay. Okay, we're going to check into that. So these were the methods I was talking about. These are change methods. Then within the same JSON object, we're passing the sender attribute, and the value is going to be the account object we created in line 11. So that is the account object to initialize and sign the transactions, okay? And that is it about our initialization function. So that is the everything you need to put in place. So this code is actually going to be the same, almost the same, if I'm not wrong, in all your web front-end framework. If in this case you're using the simple, if you just decided to go the simple way. Now, from there, we're going to see how we can log in to our smart contract or in our application, sorry. So we have in line 34, the login function. Now, this is basically going to allow the current app to make calls to the specified contract on user's behalf. So on behalf of your wallet address. And this works by creating a new access key, like I said, for the user's account and storing the private key in your application's local storage. Now, the very first thing we're going to check before we we run the login function is going to check if the user is currently logged in or not. And this is a function that is availed in line 26. So this is basically going to check if a user is logged in. So from our wallet connection object that was availed globally, we're going to run the is signed in method. Again, this is just this is availed by the near API.js. And this one is going to return either true or false based on whether the user is signed in or not. So that is it. So if the user is not signed in, so you realize if it is false, we are negating that and we're making it true. We're going to invoke from our wallet connection object that we availed globally, the request sign in method. So this is a method that directed us to our wallet address while I hit on the login button. Okay, so this is what directed us to our wallet interface, and we were able to select the wallet that we wanted to sign in with. So right here we pass the contract name. So basically the contract requesting, or the smart contract requesting access. Okay. Then we pass in the app name. So app name is optional argument, and yeah, we passed in, I availed that in our config.js file as well. So otherwise, if the user is logged in and they try to log in again, we'll basically display an alert message saying that already logged in as, then we get the account that is currently logged in. And again, we are having this get account method, which has been availed in line 30. And the get account method, using the wallet connection object that we availed globally, we invoke the get account ID. And the get account ID is basically going to return to us the currently signed in wallet address. Okay, or the wallet address that has been used to sign into our application. So again, this is coming from the near API.js library. Awesome. And that is it about the login function. Let's head on to line 49, the logout function. Again, these are spread functions I've used right here. So in the logout function, again, we're going to check if the user is logged in, which in this case, if they are, we're going to invoke the sign out method of the wallet connection object that we availed globally in our initialization function. And this sign out method is basically going to unlink the wallet address that was linked to this particular application of ours. And that way, the user will have logged out. Okay, so after doing that, we'll just reload our page for us to make everything work as expected. But if the user was already logged out, so in this case, a false value was returned after executing this function, then we'll just display to them an alert function telling them that, hey, you're already logged out. Okay, and that is it about the logout function. And now let's head on to our smart contract method. So the methods that I'm going to talk about right here are specifically going to be invoked from our smart contract, or in our smart contract, the one we wrote, the wishlist smart contract we earlier wrote in Rust. Now I'll just, let's start with the add car method. And again, in our add car method, guys, if you have any question, please put up your hand. Uh, Cosmas, you're trying to say something in the chat. Maybe I didn't get it. You're saying there's a typo in line 61. Cosmas, maybe you can just unmute and raise up the issue, if you don't mind.
Line 61 should be methods, not methods.
Oh, let me see.
Just a comment.
Oh, yeah, sure. Methods, thank you. The smart contract methods, that's true. Great. Now, the very first function we're going to talk about is the add car function. Now, our add car function, if we check, if you recall, I don't know if I can display this. Let me see if I can display this so that we are able to relate to what we actually did from the CLI. So we're actually going to perform the functions or the operations we did from the CLI of our wish list smart contract. Okay, so let me just pull the call script that we were using to perform our CLI operations. So I'll just go ahead and display that in our VS Code. Can you guys see that? Okay. Now, you realize in our CLI commands, our add car command was accepting the following parameters: the image, the name, the model, mileage, year, and price. Okay, so that is exactly what we're accepting at this point as well. So we're going to expect the user to provide us with the image value, the name value, the model, mileage, year, and price. So that is what you're capturing as the parameters. Then the very first thing we want to do to avoid unnecessary errors within our application is to check if the user is actually logged in. So that is what we're doing in line 66. Then in line 67, we invoke the contract. Sorry, guys. Let me just have this connected to power first. Awesome. So we're basically going to invoke our add car method. Now, again, let me get us back to our initialization function, maybe, for us to be able to see this well. Now, in my initialization function right here, we had under the change methods array, we had the name add car. Now, and after all these operation, we stored the contract object under this variable contract, which we availed globally. And now, from that global object, our global contract object, that is what we initialized right here, we are invoking the add car function. So that is basically how we do it. So as it appears in your smart contract, the add car function, then this add car function is going to accept, the very first parameter is going to accept is a JSON object, which is going to contain an array, which is going to contain the arguments or the parameters that our smart contract needs you to provide. So in this case, if I head back to the call script again, here is how they appeared in our terminal: the image, the value, name, value, model, value, and all that. So back in our JavaScript file, we could as well do that: image, name, model. But for simplicity, JavaScript allows us to, just provide, as long as the image, as long as the parameter rhymes the attribute needed within our JSON object, then we can just pass it down as it is. So that is what, that is basically what we are passing right here as the attributes to our JSON object. Now this function is accepting the very first parameter it's accepting is a JSON object. Put that in your mind. Then the second parameter is the gas that we want to attach. Now, if let's say this function, we were not going to attach any token or any amount while calling this particular function, then we wouldn't need this part. Okay? So we will just remove that and our function will still function correctly. However, our function requires us to provide some amount. So right here, if you can see my terminal, after signing it, that is by passing the account ID as this, we have to as well attach some near tokens to this particular call or transaction. Now, this is how we were achieving that from our CLI. However, the only way we are able to achieve that from our web front end is by providing the second and the third parameters, where the second parameter is the gas we are going to attach. So in this case, I've attached 3 teragas. Then the third parameter is going to be the amount of near in Yocto near. Okay, so the simplest unit of a near token is Yocto near. Now, we're going to provide to attach or to specify the amount of near tokens we want to attach to this particular transaction in Yocto near, and this is the value. So this is basically 1. Then I have 24 zeros after that, after 1. Then this is also going to be an asynchronous call. So I'll basically wait for it to finish, then store the response in this variable. Then right here, I'm basically returning the response. And if there was an error or something happened, I'll just return null from that function. So that is how we invoke our add car invoke our add car function of our smart contract. Now, let's see how we can read our read our wish list records. Okay, line 84 to 90. Right here, there's this read wish list method. And again, guys, this function name can be different from this function name. So they don't have to be the same. I can name this anything, and it should be able to work. However, whatever name you're going to provide here must appear in either of these arrays, depending on whether it is a view method or a change method. Please don't forget that. So we'll just revert back to what I had. Now, to read a wish list record, we again need to first check if the user is logged in. In this case, we're doing that in line 85. Then if they are, then, okay, if they are not, we're going to return an empty array. However, if they are logged in, then we'll invoke the read wish list on our contract or smart contract object that again we availed globally in our init function or initialization function. And our read wish list method was listed among our change methods. So down here, we are doing contract.read wish list, and our wish list is going to accept 2 parameters. In this case, the start and the limit. Again, let's have a look at what we did from the CLI right here. So line 9 of our call.sh, you realize that we were calling near call given the account where we deployed our smart contract, then the method name read wish list, and then there's this JSON representation of what we're going to pass as parameters. So we had the start, or we required the start and the limit. This is basically going to paginate the response. Okay, so in our from the web front end, we pass them. We pass that still as a JSON object, as you can see, giving the start and the limit values. So we're capturing these values from, again, the user is going to pass this down to us. So we just capturing them as parameters to these methods, as parameters of this method, then you're passing them down to our read wish list method. Then we're also going to wait for this operation to finish. Then you're going to store the response in this response variable. Then you're basically going to return that particular response. And like I said, if the user is not logged in, then we'll just return an empty array. So at this point, we definitely expect an array of car objects, right? Yeah. So that is it about the read wish list method of our smart contract. Let's move on to, I'll not cover this. I'll not cover line 100 because I've not implemented it within our interface, but you guys can be able, you should be able to know what's actually going on with our cross contract method. So basically that is how you do that. You'd actually implement it. But let me talk about the delete car. Now, delete car method of our smart contract right here is also among the change methods that we provided while initializing the contract object in our initialization function. Now, our delete car, if we can have a look at what we did from our CLI, is we were providing this ID parameter, okay? So this is basically what we are doing up here. We're providing that ID. So again, as a JSON object, provide the ID, and we invoke the delete car function on our contract object. So we're also going to wait for this operation to finish, and whatever value that is going to be returned to us, in this case, the object that was deleted, the vehicle object that was deleted, is going to be stored in this response variable. Then you're going to basically return that. And if nothing happened, then we return null. Okay. Now, this is that is all, or that is how we go about invoking our smart contracts methods. Now, let's have an overview of what's really going on in our index.js file. So right here, I'm basically having a series of conditions. So the very first thing I'm going to do is check if the path, so in this case, the page that the user is trying to access is an authentication page. So if it is auth.html, and I'll first check if the user is logged in. So if they are, then I'll just redirect them to index.html. However, if they are not logged in, then I will query the login button element within our HTML. Then I'll listen for any click event from that button. In which case, if it is clicked, then I'll simply invoke the login method of our utils.js file right here. So this is the method that I'll invoke. Again, so that is it about the first if statement. So line 12, we are doing an else if. So else, if the user is not on this page, then I'll check if they are on the new.html page. So in this case, the page you're going to use to add a new car record to our wish list. So if this is the case, then I'll again first check if they are logged in. And if they are not logged in, then I'll direct them to the authentication page where they'll have to log in first. However, if they are logged in already, then I'll query a form element, in this case, the new car form element, and I'll listen for an on submit event or the submit event. Then the very first thing I'm doing in line 23 is preventing the default behavior of the form while submitted. So the refreshing behavior of the form. Then from there, I'm accessing the data I need or as captured from the user in the form inputs, the name, image, model, mileage, year, price, and all that. Then given or after accessing this record, I'm going to invoke our add car function, whatever we defined in our utils.js. And again, I said, you can call this function anything, this one, but then this one has to appear among the method names you availed within your initialization function. So I can call this, let me call this add car. Okay. So with that function, I should be able to come here and just do add car like that. Okay. So this is basically going to provide these values as parameters to this add car function again, right there. You realize mileage and price of our add car method. So mileage and price, I'm doing some conversion. Why? Because while capturing this information from the form, it is coming in form of a string. However, our add car function of our smart contract, in this case, this function particularly, expects this value to be a U64 value and the price to be a float of 64-bit as well. Now, for me to be able to achieve that or do the conversion, I use the number object. So this is given out of the box by JavaScript. Then I invoke the pass in. So this is basically going to convert my string into a number or an integer. So that's what's happening right there. And if our add car is not equal to null, in this case, it was successful, we're going to be redirected back to our index.html. Otherwise, we basically reset the form. Now, that is it about the new the operations that are going to happen in our new.html file. Now, in our main file, that is the index.html file, we first of all going to check if the path is actually index.html or slash. So there are two ways index.html or the entry page can be represented, and that is what it takes. So the very first thing we do as usual is check if the user is logged in. If not, redirect them to the authentication page. Then we're going to query our wallet ID element in our web page. Then we're going to assign its text content to the wallet address. In this case, we're using the get account method to get the wallet address that is apparently used to sign into our application. Then I'm going to as well access the logout button element in our HTML file. Then I'm going to listen for any on-click event in which if the user is going to click on that button, then we're basically going to invoke our logout function. Again, this function is from our utils.js file right here. Okay. Then after logging, okay, if the user clicks on that, we log them out. Then we basically do a reload. Then the last line, that is line 71, is going to display the wish list. Now let's have a look at what this display function is going to do. So the very first thing it's going to do is going to wait for read wish list. So again, this is the function that we have over here. So this function, I'll just change it to read wish list, then make the same change over here. So this function is going to accept our start index and the number of records we need returned, that is 50 in this case. And we expect it to return an array, okay? That is basically what we are seeing from our CLI while invoking the read wish list command. So after accepting this array or returning this array to us, we're going to loop through accessing every car object. Then we're going to sort of format this car object into an element, an HTML element. Okay, so you're going to pass in the index of this car and the car object, and the car element method is down here. So we're basically using these are HTML element that I formatted. So I'm just passing in the values, and I'll be adding it or updating it in the DOM later. Okay, so after passing this value, it gets formatted. Then I basically return this as a string. So that is what happens right here. Then after returning this string, I append it, or I concatenate it, or I add it to whatever string I already have at this variable, the car records. Okay. So after all that has happened, depending on the amount of records of car I have within my wish list array, I'll simply update the DOM. So in this case, update car records. And in updating car records, I basically query the car records element. So in this case, the car record element is actually a table body, right? As you can see right here, the table body. Then I'm basically trying to update the inner element, the inner HTML elements of that particular table body element. So to update that, to update the DOM, I simply assign whatever string I have right here as my car record. So what will be passed down over here, what we are passing down right here in line 86. So guys, that is basically what's happening. And that is, yeah, that is basically it with our simple front-end, web front-end to our wish list smart contract. Now, with all that in place, we were able to come up with all these, with this particular interface. So I really hope you are at a position, you're at a position of coming up with your own web front end. So let's go ahead and add some information or some record right here and see what this is going to give us. So this should redirect us to our wallet for us to be able to attach some near tokens. That is one. So I just go ahead and approve that. Then the transaction should succeed. Then direct us back to our application over there. Then hitting on the back button, you're brought back to our index.html page. There's a bit of delay because of the asynchronous functions we have in our application. And yeah, there is the data of our car records as inputted. Yes, up to that point, is there any question from anyone? Any question from anyone? Anything you feel you've not comprehended clearly or well? You can just put up your hand. I'll give you some chance to talk, or you can put it in the chat if you have any question. Is there any? So we are good to go, right? I really hope that we are good to go. So I'll be pushing these to a GitHub repo, then sharing the link with us. And as well, I'll try and host it. So once we are done with the front end concept, I'll just avail this online or push it online. Oh, I think there's one functionality I didn't showcase, and that is the logout functionality. So if I click on that, I'll basically be directed back. Sorry guys for that. I'll be directed back to the login page. And if I try to refresh, you realize I'm still stuck right there until I log in. That's the only time I can be able to proceed with the operations. Yeah. So that is it about our car wish list application. So this is a qualified decentralized application. Okay. So if you're on this course and up to this point, this is our day 11, you now qualify to develop a fully fledged decentralized application, because you realize that we're not using any centralized database or server anywhere within our application to store data. Our data is stored on blockchain, and every other operation we are doing is coming from our smart contract, which we deployed on the near protocol blockchain. Okay. No, Alan. Well, Alan is trying to inquire if you can talk to our smart contract any other way other than the near API JS. Now, apparently there's none. Apparently, but okay. I think that answer is incorrect. So, okay, we have libraries depending on the language you're using. Okay. Now, our near CLI in the background uses the near API JS module or library to execute all that command we were doing previously. And our web application right now is still utilizing the same library, near API JS, for us to be able to perform all the operations we've been able to perform now. However, there are libraries coming up, Python, C, C++, we have Flutter, which you're going to be able to interact with the near protocol blockchain. If you're a mobile developer in this case, and you're using Flutter framework, Flutter uses that programming language, right? So if you're a Dart programmer, then you'll be able, there's a library specifically for that. So you'll be able to make these very same calls we are making from our web frontend. I think there's also one coming up, if I'm not wrong, for Python and C programming languages, which the developers in those respective languages can as well use to interact with their smart contracts on the near protocol blockchain. So yeah, there are libraries. Most are work in progress, but already there are some in place that one can utilize. So I really hope that addresses your concern, Alan. Yeah, if you can create one, and yeah, in fact, I think the Near Foundation can reward you for that. If you can just create a library that is going to interface developers to their blockchain. Okay, so let's say you're going to do a library that which PHP developers, okay? If you can do a library that PHP developers can use to interact with the smart contracts on the near protocol blockchain, then I believe these people will be more than willing to reward you for that. Yeah, so again, there are projects that one can definitely take up. And that library is already being worked on for the Flutter projects, but I think this one is good. So unless you want to do it differently, but from what I know is there's some work going on in that area. Yeah, maybe you can participate in the development, or if you want to reinvent the wheel, still well and good. You can do an open source project, then invite other developers to, you know, develop it further or make it better. Yeah, so that is still possible. That is still going to be possible. Okay.